So let's talk about what these functions look like. So the square root function pairs each real number with its principal square root, okay? So here I have f of x equals the square root of x. So if I took the square root of 0, that's going to be 0. If I took the square root of 1, that's going to give me 1. If I took the square root of 4, that'd give me 2, and the square root of 9 gives me 3. My domain is from 0 to positive infinity, and my range is also from 0 to positive infinity. This function is continuous over its entire domain. I don't know if I've brought up the term continuous. I know I have in class, but basically for the importance of our course, it means I can draw it without having to pick up my pencil. That's what we're gonna use as our definition for continuous. A cube root function, right, pairs each real number with its cube root. So that makes sense because I can take cube roots of negative numbers that my domain is from negative infinity to positive infinity. So for example, the cube root of negative 8, negative 2. Cube root of negative 1, negative 1. Cube root of 0, 0. Cube root of 1 is 1. And the cube root of 8 is 2. This is also continuous over its entire domain because I can draw it without having to pick up my pencil. So how do I go about graphing radicals? So the first thing I want to do is I need to choose my x values. And I'm going to find my x values by setting my radicand, that's what's under the radical, equal to perfect squares, cubes, or fourth roots, depending upon the degree of a radical. And I'm going to use these to solve for y. And it's going to make my y values really nice, right? Because we're working with radicals, we could possibly get irrational numbers. We could get points that really aren't on our, that are on the graph, but like are a radical and are therefore irrational numbers and hard to, pinpoint exactly that coordinate pair. So I'm going to set x minus 3 equal to some perfect squares because I have, I'm taking a square root. Friendly reminder, the first few perfect squares are 0 squared, which is 0, 1 squared, which is 1, 2 squared, which is 4, and 3 squared, which is 9. So I'm going to have 0 equal x minus 3, 1 equal x minus 3, and 4 equals x minus 3. I solve for x in all of these, right? And that gives me some really nice x values. So I get 3 equals x, 4 equals x, and 7 equals x, which I've conveniently already put in this table. Now I'm going to go ahead and find my y values, and you'll notice something kind of neat. So if I have f of 3, that's going to be the square root of 3 minus 3, which is 0. Oh, interesting. We set our equation equal to 0, and we got x was equal to 3. Okay, let's try this again. If I have f of 4, that's going to give me the square root of 4 minus 3, which is the square root of 1, which is 1. Oh, which is what we got when we set x minus 3 equal to 1. Interesting. Let's keep going. So if I have f of 7, that's the same as the square root of 7 minus 3, which is the square root of 4, which is 2. Look at those nice points. Those nice points that are not radical and are conveniently equal to the squares of everything we set ours equal to, because we've got 1 squared, 2 squared, 0 squared. So now I have 3 points. Let me see, am I graphing on the next page? No, I'm going to graph right here. So I have to graph kind of tiny. Sorry about that. I didn't include any graph paper in this slide. So I have when x is 3, y is 0. When x is 4, y is 1. And when x is 7, we erase a little bit to make our coordinate plane even bigger. When x is 7, I have that y is 2. So here is what my beautiful radical looks like. It's always going to look like a little bit of an arm. Now notice something. We've talked about parabolas before. We talked about parabolas in chapter 8. And when we were working with parabolas, we learned that if we had something within the parentheses of the square, it would shift my graph to the left or to the right. So here we were, our original graph that was over here has shifted right 3. those rules for the translation of quadratic functions also work for radical functions. So let's take a look at this next slide. So if I have the square root of x plus 2, that's going to be the graph of square root of 2 shifted up 2, right? Because if it's outside the radical, you shift them, that's a vertical shift. If it's inside the radical, it's a horizontal shift. So here I'm going to have my graph of the square root of x, but this time it's shifted not left but right 2. So let's go ahead and graph f of x equals the square root of x plus 2 and f of x equals the square root of x minus 2. And we're going to do that by finding 3 values. So we need to set what's under our radicand equal to perfect squares. So let's get a whiteboard going. I'm going to switch to orange because it shows up better on the whiteboard. So if I have f of x equals the square root of x plus 2, I want to set what's under the radicand equal to some perfect squares. Oh, well, I guess I don't have to solve for x because it's just x under my radical. So I have when x is 0, 1, and 4, I know that's going to give me some really perfect y f of x values, right? So if I have x is 0, that means the square root of 0 plus 2, which is 2. If x is 1, I have the square root of 1 plus 2, which is 3. If x is 4, I have the square root of 4 plus 2, which is 2 plus 2, so 4. Now I found 3 beautiful points on my graph. Let's draw a wonderful coordinate plane. All right, I'm going to change colors very carefully as to not clear my graph. So I have when x is 0, y is 2. I have when x is 1, y is 3. And I have when x is 4, y is 4. So here's my radical graph. I know it's going to look like this. So this was our original graph that we had, except now it's shifted up 2. And we did that using this vertical translation. Okay. Let's go ahead and clear the board and solve for f of x equals the square root of x minus 2. So I take what's under my radicand and I set it equal to the first few perfect squares. I do this because it means that when I'm solving for my y values, I will get real values that are rational as opposed to irrational, which are hard to graph. So here I have x equals 2. I add 2 to both sides, I get x equals 3. I add 2 to both sides, I get x equals 6. So I'm going to go ahead and have my x values of 2, 3, 6. So the square root of 2 minus 2 is the square root of 0, which is 0. The square root of 3 minus 2 is the square root of 1, which is 1. And the square root of 6 minus 2 is the square root of 4, which is 2. So I'm going to go ahead and graph this. This has been a horizontal translation. I shifted my graph to the right 2. Okay, so I have when x is 2, y is 0, when x is 3, y is 1, and when x is 6, y is 4. Here is my graph of my new parabola that has been shifted to the left 2. It's not a parabola, sorry, it's a radical function. That's been shifted to the left 2. Every point's been shifted to the right shift 2. All right.